we're looking at Wireworm and IPM, integrated pest management. I'm Hugh Blogg. I was the coordinator of this field trial, this IF Innovative Farmers Field Lab. And we're going to be doing a bit of a dive into the results and discussing the trial and what we were testing. Just very briefly, we're looking at biofumigants, buckwheat and mustard, and incorporating those into rotations to see how they might help to control wireworm populations, as they are causing quite a significant amount of damage. But as I say, we're going to dive into that in much more depth in a moment. Let me give you an overview of today. We've got this is the agenda, brief intro from me, and then we're going to have a kind of wireworm specific introduction from Ben, and then we're going to dive into the trial and give that a good kind of 40-minute section there. Motivation, problems, conclusions from all of the participants of the trial. I'm going to introduce them properly in a second. Then we'll move to the Q&A. So that's the kind of halfway point, I suppose, around 11 o'clock, 11:05. Yeah, just to say about the structure, probably if there are any clarification questions, then put them in the chat. But otherwise, maybe the kind of the more broader explorative questions, we'll address them in this section. So broadly speaking, up until 11:05, we'll hear mainly from the speakers, and they'll be disseminating and discussing the information. 11:35. So then we'll play this a little bit by ear. This might come forward. We're going to hear from Martin a little bit further background on wireworm, and then we're closing. So yeah, I've introduced myself. I'm from Soil Association, horticultural advisor. We've got Ben Clunny here from Harper Adams, Martin Cox, director of Blackthorn Arable. Richard Griffith is going to be called Griff. That's how he goes by, Griff from Produce Solutions. And we were going to have Will from TCNN Taylor Limited, this Shropshire-based organic farm. That's where the trial took place. Unfortunately, he's been pulled away by some work last minute. So that's the kind of the nature of this, isn't it? When we're involving farmers, there's a lot of pressure to also deliver those goals on farm. So, but we will be receiving some of his insights via Griff and the other presenters anyway. So thanks for his input in this trial. And thank you all for being here, the speakers and bonus Cat. It's really good to have been on this trial with you.
It's a dog.
And I'm going to... Oh, is it a dog? Sorry. Yeah, don't leave the identification up to me. So, yeah, going to hand over to Ben now. Thanks very much.
That's excellent. Thanks, Hugh. So I'll just give you a nod when I need to move on to the next slide. I'm going to keep this bit reasonably brief. Having a look at the attendees, I'm aware that most of you will be aware of what wireworm are and the problems associated with them, but also aware that some of you may not. So we're going to briefly run through this, and then Martin's going to expand on the whys of all of this and why they're a problem and exactly how we're aiming to deal with them. Yeah, moving along. Okay, so wireworm themselves are the larval form of the click beetle, which belong to the family Elateridae. So there's about 9,500 species in this particular family, and a small, comparatively small anyway, subsection of these are agriculturally significant, so causing some sort of economic damage to crops. The larvae themselves, thin cylindrical bodies, and as they get older, so they can be anywhere from sort of 2 to 5 years within the soil profile, some are in with dead wood and other substrates, they get reasonably tough, dark and sclerotized, and that's where they get the name wireworm. They're just pretty durable individuals. The adults themselves tend to get up to about 3 centimeters long or so, and they're named for this audible click when they right themselves. So hopefully that GIF is working for everybody else. Debated exactly what it's for. The sound itself might be a bit of a predator deterrent. It may be a solution for getting themselves out of their pupal case. A few different disagreements about that, but it's ubiquitous across the family for that. All right, move us along, Q. Grand. So this is a bit of a representation, a very general representation of the life cycle, focusing on one particular genus which we come into contact a lot within UK agriculture, which is Agriotes. So Agriotes is a combination of several different species, but they're very difficult, if impossible, to identify as larvae, and a suite of a pest complex, or part of a pest complex within the UK, but they all generally follow this sort of trend. The larvae are developing in the soil, and this number you'll find disagreed with pretty much anywhere you find it published, but anywhere up to 5 years or so, and that really depends on the availability of food and the weather conditions. What they're very good at is sustaining themselves in poor conditions, which is why within field rotations they can become a bit of a major problem. The adults themselves will emerge around springtime, start laying eggs, hatching around summer or so, and everything, when the soil's quite dry, will go back down, come back up when it's warm enough to feed, basically. Spring and autumn are when we're really finding the larvae within the soil. All right, next slide. So this graphic was taken from a recent review we were looking at specifically on biofumigation, actually, but it gives a sort of indication of the count of agriculturally relevant species and a little bit of an indication of their global distributions. This is far from a UK problem, and that species count is incredibly conservative. Okay, so in terms of the USA and mainland Europe, we tend to find the pests that are affecting agriculture a bit more varied. But as you're going to find out, that's becoming that knowledge is becoming updated, I suppose, in terms of the UK and elsewhere in the world, where people are recognizing exactly what they're looking at and the effects of each of those species. But it's a global pest and requires a lot of regional specific knowledge to be able to tackle it. Next slide, thanks you. So what's high risk for this? And what you'll find is everything I'm telling you will sort of get blown out the water with a lot of the agronomic observations and what we're tending to find in wireworm trends at the moment. But long-term grass or pasture is a pretty favourable habit for oviposition, so where the adults are laying their eggs, but can include cereals in rotation. Basically, if you've got green cover, click beetles will lay their eggs within it to some degree. South facing generally, because you get a better consistency of temperature, and generally heavier soils. But wireworm are becoming more of an issue in the east, where tend to towards more the sandy side of things, but if it retains more moisture, generally you have more wireworm, as a rule of thumb. Anyway, next slide, thanks you. What are they a problem in? And really everything. They're extremely polyphagous. They eat anything that grows within the soil, even if it's not particularly beneficial to them, which can be a problem when we're considering cover crops, which again will become illustrated later. But these earlier instars, these very small larvae, can actually potentially sustain themselves on either soil organic matter, which can be debated, but really minimal amounts of available food within the soil profile. Generally associated with pasture, and these early instar normally root feeding, but later instars are non-prescriptive. If it's growing in the soil, if it's present in the soil, they'll eat it. Potatoes, carrots, alliums, cereals, etc., etc., etc. It may not cause complete eradication of the crop. It may just be aesthetic damage, but if it's growing in a field, wireworm will find themselves on it. There's not many areas I haven't dug a hole, which tends to be a large part of my job, where I haven't found wireworms, at least somewhere along the line. Next slide, thanks you. Okay, so all of these conditions, all these abiotic conditions I'm going to throw at you have come from various literature reviews which I've done on the pest itself. And again, as Martin's going to highlight as we're going through, they often don't abide by their own rules. Okay, so there's limited vertical and horizontal movement because they are small, but I think it tends to be more than we expect. In winter, they can just get themselves low within the soil or become static, have some sort of pupal case within the soil profile. The activity, so the active movement in that soil decreases below about 8 degrees. If you're sampling for wireworm, for example, you really don't want to bother unless your soil temperature is above that. And they will, as any animal will, take the route of least resistance, and they'll prefer existing soil burrows. You can see here a picture from last week where we were digging up an area of high earthworm activity and finding a lot of wireworm traversing in their burrows. This vertical migration to come up to try and more actively feed will happen normally around spring and autumn, and avoid those drier temperatures. If you want to kill a wireworm, it's desiccation, it's drying out, which is going to do the biggest damage. It's obviously difficult to do that. So March to May and September, October, we tend to find our biggest areas of activity. Next slide, thanks you. So continuing these environmental preferences, we've got that optimal soil temperature of 11 to 13 degrees, but this again was focusing on one specific species. The common theme throughout is that we're really lacking a lot of the ecological knowledge for the specific species within the pest complexes which are affecting our crops. It tends to be more general, or work is just done on a particular genus or just wireworm. So we're finding a lot of or a lack of resolution in a lot of the research going on. Got a bit of an optimal soil moisture. Too wet, there's drowning, or lack of movement or available resources. Too dry, they will desiccate. Tend to be more active in acidic soils. That also is variable, dependent on species. You'll find continuous feeding at about 20 to 24 degrees. So that's obviously reasonably high for us, and that is dependent on the relationship between moisture, humidity, everything else. If it's going to be that warm but also dry, they'll struggle. Intermittently will feed 1 to 10 day breaks at 8 to 11 degrees. So basically, as the temperature comes down, they will feed to sustain themselves, but their life cycle will massively slow down, which is why they can sustain themselves in the soil profile for such a long time. Next slide, thanks you. Okay, so just to wrap up the introduction to them, why we're here, why are they an issue? And the complex ecology of wireworm and agriculturally important species means that any control solution that arises, and we're obviously losing conventional controls at a rate of knots, rightly or wrongly, we'll get into that, I suppose, at some point. But this complex ecology means any control must take place throughout the rotation. IPM in general, although it involves conventional controls, is moving away from this concept of silver bullet control. Nothing as an instant curative solution that isn't generally ecologically damaging. So we need to consider these elements pretty thoroughly, and there's obviously a lack of knowledge on specific species. Any future solutions have to incorporate this approach, including prediction modeling, of which variations do exist for the UK, for France, in Canada as well, where they're a major problem. But it needs to be taken further. Species-specific abiotic factors, field history, planting schedule shifts, more localized conditions needs to take advantage of all of this, and it's currently not at a level at which it's doing so. And there's this question of monitoring and application. It's crucial. They're both labor and time intensive, as you will find out from Martin. There's a picture of us both at some point within the last few years. I think mine might be almost a decade old now, digging up wireworm. It takes a lot of time and effort to decide what's in the field, and actually then determining how much of a problem it's going to be on the crop eventually can be variable as well. So there's a lot of work to be done in that area, but that's what you're here to find all out about. Final slide, I think, Hugh. Grand. So this was everyone involved in the project. They'll get mentioned at some point throughout the rest of the webinar, but I think it's probably time for me to hand over to the next speaker.
Yeah, thanks so much, Ben. Can you still see the full screen presentation? Just had a moment there.
Yeah, it's fine.
Good. Yeah, thank you. Thanks for that intro, Ben. Martin's going to move us on to now looking at the specific trial field lab that we've been conducting this past year, or even more. The idea's been brewing for a while. So over to you, Martin. Thanks.
Okay, if you move that one on.
If you move that slide on here, please. Yeah. Okay. If you just go back to that one, I'll just reiterate these are, yeah, you went on 2 slides, mate. Yeah. So these are the people who are involved. And Nick hosted it, I'd like to say, which does take out, for any grower hosting a trial, it takes out a lot of work, a lot of time. Hutchinson's played seed, very good of them. Innovative Farmers Stroke Soil Association, the people who managed and funded it. Harper Adams is where Ben operates at and did lectures at. Produce Solutions actually did the trial, and I'm here. I actually think, I think I instigated this trial with help from the guys at RB Organic, Chris Negus, who contacted Soil Association. So that's the story behind it. Why did we do it? Because there are damn problems. So if we move on next. Yeah, so that's a picture of the site from my drone taken about when we started the work. So you can see some plots are bare, some aren't, and that's the size of it. It's a reasonably big plot, so we could actually move machinery about. If we go on one more slide, please. So yeah, why did we propose it? Was because we know that stubble management is important. We know that sites with weedy stubbles, as I call it, so that's a stubble you combine your cereal crop, you harvest it, and then it regrows, volunteers, weeds, and whatever else you happen to have there. Most of that stuff that's growing will be a superb food source for wireworms. And the juvenile wireworms, the small ones, are particularly require this food to build themselves up for the first winter. So we talk about juveniles, neonates. The neonates are really freshly hatched, I'd say, first up to the first molt. After that, we talk about juveniles. These are going to be, at that stage, a couple of mil, up to about 3-4 mil in the autumn, and obviously they're very prone to predation by fungi, other wireworms, and other insects or inhabiting insects. So anything we do in a stubble will have a matrix of effects, and we don't know exactly what they are. There are a lot of we know what's bad, but we don't know what's particularly good, and there's lots of ideas floating around, often marketed by people with cover crops to sell. So if we move on to the next one, please. So, but yeah, basically the move to regenerative farming does potentially put pressure on this, and we basically had potato growers, agronomists, and researchers say it's a good group. You've got the grower, you've got agronomists, me and Griff and others, and you've got the researchers like Ben, and it's a good mix. If you've got that mix in a project, it's going to have the scientific rigor, and it's also going to be practically driven. The main interest in buckwheat and mustard has come from work done in Canada by Christine Nerona. I happen to know Christine, and she's been very helpful to me in my studies. And they produced data that indicated that buckwheat and mustard could reduce wireworm populations in soil. That was kind of leapt upon as something that would, if we put mustard in, if we put buckwheat in a cover crop, we'll get rid of wireworms. And I don't think, I mean, even Ryan Barrett of PEI Agronomy there was quite amazed. While I was talking to him at Harrogate in 23, he was quite amazed what we were doing. He said, I don't believe that will be there long enough. So we needed to look at this. So next slide, please. So I think Griff comes in at some point here, but so we basically looked at whether or not a mustard buckwheat just planted in place of a regrowing stubble. We also had regrowing stubble. We had cultivated stubble. We were aiming to do mustard and incorporate that as a biofumigant, but it was a very wet autumn. We could not do it, and there was no point in doing it. Soil moisture levels were too high. soil's too cold, not an option. It's been difficult to do this work, and we basically were looking at, will buckwheat get rid of them? Will mustard get rid of them? Will a growing stubble make them worse? Does a bare stubble help? Does it have to be cultivated? And one of the interesting things was we had to use a flame weeder because it's an organic site, and we'll get onto that a bit later. But the key thing is that wireworm, the older larvae, will go a long time without living plants. They only really need living plants for a period in their youth, which may be up to the first autumn. It may be less than that. We don't know. Next slide, please. Yeah, so this is kind of work they did in Canada. This is some of it that's been published in various ways. And BW is buckwheat and barley. So they're showing that there was fewer wireworms in this was wireworms trapped in a cabbage field or something. And they're showing many more in a clover field, more in barley generally. Doesn't look like the disking is actually making a lot of difference. And I would say that it will make a difference if it's done at the right time of the year. But it's pretty critical. Next slide, please. So I want to emphasize that what we're talking about here is 2 years of buckwheat or mustard, and that is 2 years and 2 crops per year. So essentially in the spring, whenever that is, in Prince Edward Island, it's not as far north as you'd imagine. And I emphasize as well that they have the same problem species by and large as we do. They have the Agriotes, Obscurus, Sputata lineatus. They have others, but these are their problem ones. The European species, as they call them, they came in ships ballast, apparently. So after 2 years of buckwheat mustard, they found that they had significant reductions in damage compared with barley. Now that's been taken to mean that it got rid of the wireworms, but click beetles will not lay anywhere near the number of eggs in these crops as they would in a barley crop, and they're known not to be such good food species. So the chances are that what we're looking at here is either we've aged off, as Ben calls it, the larger fraction, and they've had reduced egg laying to supply the, if you think of wireworm population being like a conveyor belt, you keep putting them on one end, and if they stop egg laying and hatching, after a while, you've got a lot smaller ones. They still had damage. Mark Stallam saw this work. He said, you know, we wouldn't have marked, this is for processing, way worse than anything we'd market in a bag in the UK. He said what they call marketable isn't what we would call marketable, but the reduction is not. There's a lot more to this work. We have to read into it a lot. You cannot read into it that that's straightforward killing wireworms. They probably came to a happy end. So next one, please. So yeah, this is old work from 1942 in the UK. Just shows the difference. They don't like bare soil, fallow land, kale, clover, wheat, and you're seeing, you know, the almost not 8 times as many in a piece of grass as there is a piece of cow. So you get the message. This is a very important thing to consider in rotational risk assessment, is which crops you're growing. And I'm doing a nice little project in Suffolk with these Suffolk producers on that. So we'll see what else we can find. But carry on one more, please. Yeah, so basically what we've said is that the work that's been done indicates that once they hatch, they need living plants, and they will starve within 4 or 5 weeks in bare soil in a lab. These are tiny things. And also, if the soil is bare, there will be more predation by larger wireworms. They'll just be hungrier. So they do need growing plants, and this is in May, June time. It also emphasizes the thing that Ben's made about the moisture retention in soil. It is utterly critical. And we see in fields with variable soil, we go from really sandy stuff into loams, but the wireworms are in the loams. So it's highly unlikely you'll have a big population in very drought-prone soil. Go one more, please. So this is some other stuff they had there, which is well, I would actually, if buckwheat was a complete killer, I wouldn't expect to have been any there. But even so, you're looking at 44% surviving on a barley diet. So there's already 56% loss of larvae presumably with nothing else going on. It just shows how vulnerable they are. If you handle them in a lab, they're very easy to kill. They're very fragile. Next slide, please. So these are my points I want to raise about the Canadian work, and this is not a critique. I'm not criticizing it. It's more of a critique. It's an explanation of what we can be seeing. Now we know that you'd most likely get that effect if you grew field beans or linseed or something like that. So I think this is why we're doing this kind of work, as to which crops in the rotation do they not lay eggs in, and if they do lay eggs, the plants aren't a terribly good food source. But we do have to point out that in cover crops and such, it's very rare that you've got a monoculture, and wireworms will feed on weeds and any grasses or anything like that. So they're Ben's polyphagous. They haven't survived these 100-odd million years by being gluten intolerant vegans. So I can tell you it's difficult. Next slide, please. So I think we bring we bring Griffin here at some point, don't we? Who?
Yes, that's right. Yeah. Thanks so much, Martin. We're going to hand over to Griff to get into a little bit more of the on the ground processes and observations. Thanks.
Thank you, Hugh. Good morning to everybody. Hugh, could you just go back to the previous slide, because it's an excellent slide to give you some background. So you said the project had been brewing a while, and let me put that into context. So this field is at Nick Taylor's. It's called Cow Field. The picture tells 1,000 words, because you can see on the right of the slide there is some straw. That straw is from the crop of oats that was in the field before we drilled the trial. Ironically, it was an incredibly wet summer, and the oats were harvested quite late, which meant the trial was delayed, which had a knock-on effect that Martin alluded to with regards to the incorporation of the mustard. So why was it been brewing for a while? Well, the trial was actually going to take place in 2022 on the back of the fact that in 2021 on that field we had a crop of potatoes. It was being harvested into boxes. I was there when it was being harvested, and it was just like someone had thrown a fish bait box onto the floor of the trailer, because it was absolutely crawling with wireworm. I've never seen anything like it. So when the consortium approached us about doing the trial, I said, well, we've got an excellent site here, because it's clearly a serious wireworm problem. So in 2022, that was when we were planning to originally do the trial, we put down pheromone traps to make sure that the levels of potential wireworm were still going to be good enough for the trial. And yes, we found good levels of click beetles. But 2022 was incredibly dry, and that meant that when we were looking at doing the soil coring, it was virtually impossible to get the soil corer into the ground, even though that field is quite a light field where the trial is. So that's the background to it. So we actually delayed the trial until 2023, which is the photograph you can see there. And the irony, of course, is the fact that that was the complete opposite, and it was very, very wet. And as I said before, it delayed a lot of the activities we did. Hugh, could you just move on 3 slides to the one with the trial layouts? And I'm going to ask you to flit around a bit, but if you keep going to the next one. Right, okay. So that's a schematic view of the trial. It's actually overpinned into a beautiful drone photo on the left-hand side that Martin took. So basically, Martin described the treatments that we were looking at, and the trial itself was a randomized complete blocks. So there were six treatments, and we randomized those within that trial to try and make it as replicable as possible. Could you go back to 2 slides, please, now, Hugh, to the one with the bags and the core? Next one back. That's perfect. Great. So again, as Martin alluded to, the treatments were a control stubble, which had natural regeneration on, bare stubble that we kept bare using a burner. So Nick uses a burner to control weeds within his carrot crops pre-drilling, and the same in the parsnips. Then we had the stubble which was cultivated. Then we had a plot that had buckwheat in, which was drilled at 50 kilograms per hectare. And then there were 2 mustard crops, one where we were going to just leave the mustard to grow over winter, and the other one, again, that Martin alluded to, that we were going to incorporate, but because it was so late drilled, it didn't really come to a good enough crop for incorporation. At the point in time where we thought, well, we could do something, it was just so wet that it was impossible to actually incorporate it. So the soil coring we use on the bottom left hand side, you can see the soil corer we used, and we did 10 cores per plot. And on the top of the slide you can see the brown bags there, and we actually removed around 400 kilograms of soil. So there was a fair carload of soil that went up to ADAS at High Mowthorpe. So once the plots had been drilled, we actually drilled it on the 24th of August. I just want to make sure I tell you the right things in order. So once we'd drilled the relevant crops, we actually Cambridge rolled the whole site to make sure we got enough consolidation for the seed to soil contact. And then during the autumn of 2023, we would continue with the burning. So when there was a flush of weeds that we needed to control, we'd go through with the burner on the relevant plots, and we'd go through with the cultivator on the relevant plots. And in that autumn of 2023, we actually went through 3 times on the burner and 3 times with the cultivator. If you go to the next slide, Hugh, please. So that's the equipment that we use. So the burner on the top left-hand side, as I say, is what Nick would use for weed control in carrots, and the cultivator lower right is basically a disc. And I think I've pretty much covered everything off that I wanted to. The final bit was that we actually then, in the spring of 24, I think it was the 11th of April, we then obviously went back with the soil corer, did the same 10 cores per plot, and again, a similar amount of soil, around 400 kilograms, was sent off to ADAS High Mowthorpe. And well, you'll see the results as the rest of the webinar unfolds. I think that's me done, Hugh.
Thanks, Griff. I'll just move this on. Yep. So we're on to Ben now to look at the results. Thanks, Ben.
Yeah, so as many of you will be aware, with any field trial, you've got the caveats that you've only got so much time to work with, and you've got the conditions to contend with, as the same with growing anything. Just farming, isn't it, really? So we didn't necessarily get the counts that we wanted, but there were some things to pick out, which I'll highlight here, and I think will come up in discussion later as well. So counts generally were reasonably low. across all of these. We've got before and we've got after, and there's not a huge amount of difference between the treatments, with one of the exceptions being the stubble burner there. Now, based on what I've said in the introduction and based on what Martin said, that's quite a glaring difference that we didn't have a huge amount of answer for. It's not an area particularly we'd expect to find wireworm. So to find them there more than anything else kind of throws up more questions than answers. That seems to be a little bit of a trend with wireworm research currently anyway, quite frustratingly, but that's obviously what we're trying to tackle. There is also the question of being able to identify these earlier install larvae with various methods, which is particularly difficult to see them. And anyone that's done any sampling for wireworm, it's hard enough to see the later install larvae, and you'll just as easily confuse them for a piece of root as you will for an insect. And again, as I believe Martin's going to highlight later, there's plenty of other things they can be confused for as well. The earlier install larvae can be a matter of millimeters, and unless you've really had the experience of digging 1,000 holes and looking for them, which unless you quite enjoy it, like Martin and myself, you're going to struggle to have really. So we used a flotation method with folks at ADAS, which is tried and tested and dates back, over 100 years almost at this point. But even so is not necessarily key and really requires optimum timing for making the most out of that as well. So what have we missed? Potentially some. Would we have liked to do more? Being a scientist, you can always do more. But we were constrained by everything else that went with it, really. Do you want to move on to the next slide, Hugh? So what that looks like is this in terms of the population change. So obviously negative, we're getting fewer individuals, and positive more. So in terms of the stubble, regrow, cultivate, and buckwheat, ever so slightly more, but nothing in terms of significance. Again, it's that's change in the stubble burner, which is the interesting question. It may be an artifact, it may be a one-off, but it probably warrants some further investigation there. It could be an issue of temperature. Not necessarily through direct flaming, but the soil being able to get more heat to it in terms of sun, and maybe potentially there being enough matter to sustain some feeding along with that raised temperature without necessarily causing desiccation. Could be one answer for it, but it's something that can be investigated further with other field trials. Next slide, Hugh. So in terms of the analysis that was carried out on this, no significant differences in terms of the test that we're applying to it, but we do have interesting observations. And I think when anyone's carrying out field trials, it's those observations which can often lead to the most interesting things. Field trials generally, because of the time, costs, and effort, are slightly lower in terms of replication, and they require a lot of effort and manpower. As Griff will testify to on the days that they were soil coring, it's a lot of effort to do all this stuff. So you need to maximize the results that you're getting, and these observations, I think, ultimately will be key. Discuss potentially why that flame weeding could have interesting ramifications. But we've also got this element of the soil ecological complex. It's not just wireworm in your soil. You've got a lot of other things present within that. They have parasites such as stellated fly larvae. Carabids and rove beetles will predate on them. They'll eat themselves. Larger larvae, if there's no suitable food source there, are cannibalistic. The lack of control from buckwheat doesn't necessarily agree with the findings of Nerona, which Martin's already mentioned, but it's possible the larvae are already too large for this effect to happen. Other research has noted that they will feed on buckwheat if there's nothing else there to sort of just sustain themselves, even if it's not nutritionally beneficial. They are tough once they're in the soil, and if that's all that's available to them in that year, well, the likelihood is they're just going to be within the soil for an extra season until they can get the nutritional benefit to get themselves through to pupation. So until we have this better understanding of this stage in wireworm development, when they're no longer highly susceptible to starvation, we can only really surmise at which point this occurs. So what this means really is more work, but it also means coupling this with laboratory and glasshouse work to look at these specific ecological developmental issues across all of the species, which we know are agriculturally important in the UK. Some of that's ongoing, some of that's to be started, but we're on our way, and this is a contribution towards that, and quite a valuable one as well. I think that's the end of that one, Hugh, unless we've got one more slide after that. So already discussed was this ability to detect the presence of small larvae. So again, when we are sampling by hand, we normally do this with bait trapping. Monitoring will come up in a moment as well. We're often able to pick these out by eye, but that's difficult and not necessarily reliable. So we've used this flotation methods. But at the first sampling, these larvae would be about 3 millimeters and pretty small to be able to do this reliably. So this mechanical extraction system is basically used to float them to the surface. It's something we've used across other mediums as well. And ADAS have used this similar system with slightly kinder chemicals these days to extract the wireworm from the source sample. It's the only method available, but the detection threshold is pretty high. There's evidence of it being used in similar work recently, but I think experience and reliability is definitely a question mark over this. And again, we'll emphasize that the timing of it is crucial. I think you need live larvae to be able to float them to the top. As soon as desiccation sets in and that degradation is particularly quick with these earlier install larvae, it doesn't take a lot for them to begin to degrade once they're deceased. Detection becomes nigh on impossible, really. Next slide, please, Hugh. All right, so I'm going to pass over to Martin now. A lot of those discussion points, I think, will come up again and get repeated here. But while Martin's going to talk a lot about the future directions, which are complex but promising, I think.
Over to you, Martin.
I will when I activate my mic. Yeah. So thanks, Ben, and who very competent. So we know that there are a lot of, well, sadly curtailed at the minute, but we know there are a lot of fields out there that have got all manner of things in them that are not designed to feed humans. And we don't really know what the impact of this will be, but I wouldn't say anecdotally, we know historically when we had long-term set aside, it was deemed to be on a par with the poor bit of grass. A lot of the problems of wireworms suddenly appeared after set aside. I think Mary Hancock did some work on that, but if you go back to the days Bill Parker and Bill like that, it was considered to be part of your risk assessment, grass or set aside. So these situations are not necessarily these crop situations. When they go in, they're going to be all squeaky clean, and they're going to be all various broadleaf things. But if you look at them after a year or two, they're fairly infested with grass weeds and such. There's a local one near me that went in. It was legumes, and it became full of poppies. And I looked at it the other day, and it did just look like a bit of poor grass now. So that's going to be highly useful to this pest. It's going to attract egg laying, and it's going to function, like a piece of grass, really. So we suspect a lot of these will build wireworm populations, but there's a lot of interest, certainly in the shorter options, at doing work on mixtures of unfriendly species for egg laying that we've discussed. So obviously a mustard, a buckwheat, and a linseed we would not expect that to be anywhere near as good at building wireworm populations as a cereal crop. And then if we put a cover crop in, we know that some cover crops are not as good food sources. There was some work I saw published recently, but they concluded that as soon as you put a cereal in with that mix, the wireworms fed quite well. I understand they like it's coming out of my, but the plantain, ribwort plantain. I understand they quite like that. So herbal A's are probably quite good for them. One of the problems we've got is identifying where females lay eggs, identifying, and to do a bit more work on this. It would be lovely if we knew if we could put numbers against crops in a rotation and say this is a more recent work that's been done, and we'd know we can risk assess better in a rotation, and we could say probably more accurately than we do at the moment that if you're following a cereal crop, then you need to be pretty damn careful what you're doing with cover crops, and what would the mix be, how suitable would a mix be. But to do that, we need to be able to identify these populations of small larvae in soil. And the only project, there's a couple of projects, certainly the Potato Partnership, TPP, they're hoping to do some longer term rotational basis work. But as that stands, that's just going to suffer the same shortcomings as this project has, because we still can't identify the changes in populations quickly enough. I hope that the Enigma Wireworm 2 project is able to proceed. And one of the aims there is we want to look at work investigating neonate survival on cover crops. And also, I would hope that I'm continuing to try and improve our ability to detect small wireworms in soil, which is not easy, as Ben alluded to. So what we do know is that wireworm, we are part of Ben is, I am, and Larissa Collins from FERA, Graham Tomlin in the UK. We're all members of the European Wireworm Research Network with 20 nations involved. And wireworm research is seen as fundamentally important in Europe. Put that in perspective, the French have just got €6.25 million in funding for a 5-year project on wireworms. And the guy who negotiated that and is managing that is another co-founder of the European Wireworm Research Network. One thing we do know is that the species we have in the UK, Agriotes obscurus and lineatus, they're common across most of the European countries on our latitude, all the way over from Russia right over to, and they have the same ones in Canada. So any research that's done, we can read across pretty directly as long as it's involving those species. And a lot of the work we've done already is confirmed what we didn't know what we got. We've done that work. We need to carry on. We need research that enables. We need research in a lab to build methods to do the research on rotational changes. We've done our best, but we don't have the tools available to do it at the moment. Not to the level we need to do it, and not as fast as we need to do it. At the moment, you're looking at several years to get a picture. That's just too long. You could be a long way wrong if you back the wrong horse. Can we go on if there is anything? Who?
Thanks, Martin.
Right, so will not be talking, but I'll just carry on there.
Yeah, at this point, so as I mentioned at the beginning, unfortunately, Will couldn't join his. Maybe Griff, you can speak a little bit more about why, but that's just one of the tensions of having those farmers involved that's so busy. But yeah, Griff, do you want to just give a little bit more of the reflections from the field?
So thank you, Hugh. I will do, and then I will hand to Martin, because I know Martin's got some points as well. But when I spoke to Will this morning, I think there were 3 things that he wanted to mention. I alluded to it during the beginning of my presentation. I think one of the things that they're so incredibly surprised about, that field, they saw the level of wireworms that were in that field, and they were just very surprised having a trial that big, a trial that robust, that the levels that we actually found were so low. So I think that's one of the things that they were disappointed with. But that's it. That's agriculture. I think the weather as well, it just throws up how reliant we are on the weather, and some of the cultivation, some of the operations that we did, we probably didn't do in ideal conditions. So I suppose one of their comments would be, well, if we were to expand this to a field scale operation, you know, we're going to have the same problems. And if timing is crucial, then, you know, it throws a vagary into the whole thing. The final point was that on the back of this, from this trial, Nick actually put in a cover crop with buckwheat in to just try and put some other mixes together to help with this problem. I think one of the challenges that he noticed with it is that buckwheat doesn't like cold weather, and once you get frosts, etc., it does knock it for six. So some of the crops perhaps weren't as full as he would probably be used to. But those were the three main things. And as I say, Will is incredibly apologetic about not being able to join us, but that's agriculture.
Yeah, no, yeah. So Griff, just wondering if we can expand on. I think you've covered this a little bit already, but one of the issues was the mustard, wasn't it? The timing of growing that, and that it. Could you just explain a little bit more about what happened there? We were kind of sharing pictures over WhatsApp, like trying to get it to grow, but it was a bit late, it was a bit cold, it was a bit wet.
I think there's possibly a number of things, and Martin and Ben may want to add to this, but obviously in an organic system, some of the nutrient levels are perhaps not at their optimum. We have ways of managing that, but I think one of the comments that that was mentioned from a colleague was, well, perhaps we needed a bit more of a nutrient boost to get that mustard going a bit quicker. But I think on the back of the fact that that crop of oats was harvested much later than we would have wanted, the crops actually were drilled much later than we wanted and didn't get that early start to enable them to reach the stage that we would have wanted to actually be able to incorporate them. So you're right, there were lots of WhatsApp photographs going around. Well, this is where the crop is now. Do you think we could incorporate it? But it really wasn't at a stage when the conditions would have allowed incorporation. It was a very small crop, I have to say. And then when the crop did eventually take hold and was at a stage where it would have been appropriate to incorporate it, it never stopped raining, and to be able to travel and not ruin the soil structure. So that's the other thing, the law of unintended consequences. There are lots of things that we need to bear in mind when we're looking at some of these potential solutions. So even when we were burning, even when we were disking in that autumn period to keep on top of the weeds, etc., some of those operations weren't done in conditions that we would have liked purely from a soil structure point of view.
Yeah, thank you so much. And it's really important, I think, to remember that we are on, a farm that has a lifespan beyond this trial, and that we don't want to be sacrificing soil structure, for the trial. So it's one of those complications that we came across. So thanks for expanding on that, Martin. I was wondering whether you might be able to explain a little bit more about, like, what is the ideal stage for mustard to be incorporated? How far off were we? What happens in the crop that is important? What is that stage that we were trying to get to?
Okay, well, I think anybody in agriculture knows if you drill winter wheat in the middle of September, it'll grow like hell. You drill oilseed rape. I mean, they drill oilseed rape now at the beginning of August, and they're putting sheep over it to stop it and such like. You drill oilseed rape in the end of September, and you stand and you watch it, and it's pitiful. And mustard is the same. If you drill a cover crop a month later, the above ground mass will just not get going unless you're very lucky. I saw a radish mix drilled a little bit late this autumn, and it got away, and the soil SMNs were quite low afterwards compared to some of the other fields on the farm. So we know that it must have done something. The roots get down, but it doesn't produce a lot of top. Some people would say that's quite a good cover crop, much less hassle to deal with in the spring. But if you're looking for biofumigation, you want tons per hectare of green material and these high levels of glucosinolates and the right ITCs, the correct ITCs. And the other thing is that it needs to more or less get to about flowering stage, and then you chop it in. You need airspace in that soil, so you need soil and air. You need a mixture of soil and air. And if you've got waterlogged soil, you've got a mixture of soil and water. There's nowhere for those volatiles to go to. So we couldn't do it. It's pointless. And temperature, you need the temperature to be above about 10, and the temperatures were falling. Consequence of anything, you would not put biofumigant crop in as late as we did for the very reasons we experienced. And the reason we wanted to put biofumigant crop in was simply to see what the effects of mustard are and the effects of cultivation, because in theory, the cultivation on a stubble should seriously hamper the juvenile feeding and survival. The question is, does the stubble need to be cultivated to any extent? And there are advantages to cultivating it, because you will disturb adults, you could kill pupae if they're still there, and you will find that what we saw, that wireworm feeding on stubble, me and Ben found that when we were sifting. That's quite amazing, that was actually feeding on that what looked to be absolutely no use to it whatsoever. I didn't actually know they did that. So I know it just proves what they will do. So the whole idea of cultivating is not just to kill, it won't kill what's there, it can kill the juveniles, and it may also have a bigger impact on the ones that are going to build the population next. So this is what we talk about long-term population control. The idea was to see, will mustard on its own perform a function starving them out? Does it need to be incorporated? How do we get, we've got bare stubble, we've got cultivated stubble, we've got mustard growing, we've got stubble growing, and we've got cultivation plus the mustard. So we were trying to see, was there an additive effect? We didn't, but that can be done another time. And I think that sums it up reasonably well, doesn't it?
Thanks, Martin. Yeah. Ben, did you have any insights you wanted to add at this point before we move to inviting in a bit more of an open discussion? Any more reflections from the field? I know you're on the research end, but
yeah, I think, to be honest, I think Griff and Martin have summarised it all pretty well, to be honest. So I think if we jump into questions, we can answer things as and when they arise, really.
Great. Thanks, guys. Thank you. Yeah, we're doing great according to our agenda, so that's really super. Shall I stop sharing this so that we can actually see faces a bit better, if you want to, that is. So yeah, there's a couple of questions in the chat. Maybe we'll kick off with those, but as you feel free to just make yourself seen, and with a question, then just put your hand up and yeah, we'll come to you. So there's a question in the chat. Do you think the late harvest combined with the allelopathic properties of oats suppress the cover crops? Martin or Griff or anybody?
I am going to, I didn't point out, so it's a very interesting question. So one of the things that Nick would always do after a crop of oats is to go in and cultivate to encourage weeds to grow, but any seedlings of oats that weren't harvested to actually germinate, and then he would go through with the cultivator to actually try and destroy it and encourage another flush. So we actually did that. After the oats were harvested, we cultivated and tried to encourage as much of the brock to actually germinate. someone else might like to add to that, but it's a really interesting question, and that's an operation that we did partly because of what you've alluded to.
Great, thanks, Griff. Any more comments on that, or should we move on to the next question?
Dennis has just, can I follow on with that? Because Dennis has asked a question related to that. Were there
Yes,
any follow-on oats in the trial? Interestingly, no. Obviously, there wouldn't be in the burnt plots and the cultivated plots, and actually in the buckwheat and the mustard, even though it wasn't a huge canopy, I think it did suppress any more coming through. So in answer to your question, Dennis, no, there wasn't a noticeable level of oats.
Just before we take just before we go to the hand up, sorry, just doing this in fair order. Variety of mustards sown. How did we decide upon that, and what were they?
It's in the trial report, which will be published. Can't remember what they were.
It was Vitasso, brown mustard seed, Brassica, Juncia. Is that my correct pronunciation?
Sounds good to me.
So
Vitasso, brown mustard seed.
Yeah.
The reason we would have used brown mustard is because that mirrors in Canada, Christine, and they are adamant that you need brown mustard and not white mustard or what have you. That's what they say.
Thanks.
So no caliente mustard was used then?
Nope.
Okay.
Couldn't see who was speaking there. Well, was that Andy? That was you who put the question in the chat?
Me, yeah. It's just that, I mean, I've done work with mustards on nematodes, and we kind of focused on the caliente mustards rather than the. I think we did include some Vitasso, but it didn't do much against nematodes, if I remember correctly. But
yeah, I mean we weren't looking at nematodes, obviously, and
I know,
we weren't looking at nematodes, and the reason we used the same mustard, the reason we used the same mustard in both treatments was, and we did debate this, was so that we had, I remember the discussion, it was so that we had the building block, mustard plus incorporation.
Yeah.
Now, to be honest with you, the biofumigation part of it really isn't the main deal. What we were looking at biofumigation was as a way of using cultivations to decrease the success of subsequent populations, because in wireworm work, what you do one year, you tend to see the fruits of 2-3 years later. So it was the biofumigant we were looking at. We know biofumigation is unlikely to stop larger larvae. There's previous work been done on that, but we were always looking at the effects on the small ones, and the effect of the cultivation would have a far greater effect on, for argument's sake, adults if they're in there, because they would then be subject to all manner of predation, or they'd be disturbed. They would normally spend the winter in a pupation chamber. So there's a lot more going on when we start talking about cultivation for wireworms than people would immediately imagine. What I can say is about wireworms in 1940-ish, it was concluded that the effect of salt, the people who were doing a lot of work then, Stapley, Cockbill, I think Evans, Salt, Hollick, etc., were doing a lot of work, and they concluded that the effect of cultivation was largely to create a habitat that was unsuitable for egg laying and juvenile survival. And 16% control of larvae by direct mortality was reported in that work, about 16-20%. I would ask you all to consider, if wireworms were that susceptible to cultivation, they wouldn't survive the work that leads up to a potato crop. But talking about Griff's work, those wireworms, and we do see this, you have a potato crop, it wouldn't be terribly attractive for egg laying. Any that did would be knocked out by the cultivations at harvest. any adults that pupated off would most likely be heavily disturbed by the cultivations at harvest. So you probably actually in a potato crop, you're going to create a 2-year gap in the life cycle in the process. So 2 years down the line, you will have had the big ones age off, the small ones haven't arrived, and we were about to start filling it up again from the oat crop. So that's why they won't be there. They will fluctuate up and down in a rotation depending on what happened 2 to 3 years previously. I'll stop there.
Thank you, Martin. Yeah, it's fascinating working with trying to design a trial that's within, a year, beyond a year, 2-year, 3-year implications of what's happening. Punamaki, sorry if I've said that wrong, but can we take your question? Do I need to unmute?
I think I've unmuted everyone automatically, so you can unmute yourself. That's it. Yeah.
Yeah.
Sorry.
Yeah, I wrote as a comment. I was thinking like what I understand, like this has been really really interesting. I'm really amazing to hear so much knowledge, because I'm from Finland and I'm trying to search anything and there's so little about this. But like as I understand from this, like that probably you just can't kill those big wireworms in the soil. Like it's already really difficult. Like you can't starve them, you can't like do anything to them. So the only way you can get rid of them is just to wait that they pupate. Like what's the word? Poop.
I'll jump in before mine here, because Martin will definitely have some comments on this. In a way, you're right. And the basis of this work is designed to try and age out that population. And again, that comes back to the idea of controlling within the rotation. So if you can disrupt and destroy the earlier install larvae, then yeah, exactly as he said, they will pupate and that population will age out. There are ways to kill the later install larvae. There's conventional controls which we no longer have. There's conventional controls which are being mooted sort of elsewhere in the world. There's biological controls. You can kill them with nematodes. You can kill them with entomopathogenic fungi. We've used various things like trap cropping, botanical extracts, essential oils, to stress them out and make them more susceptible to these things. The problem is, as I'm sure everyone that's working in arable crops listening will attest to, is that any biological control in outdoor crops is wildly expensive, and it's incredibly difficult to target the pest with them. So one such example of this, which was registered over in Germany for a time, was a product called Atricap. I can see Tony Little's face on the screen. He'll be aware of Atricap, as I did a small trial with him going back a fair few years now, which incorporates an entomopathogenic fungi with yeast to produce a CO2 gradient. The main way that they'll find food within the soil profile is CO2. If it's producing CO2, it's growing, therefore I can eat it. There's some discussion about short range volatiles providing suitability, but we've seen wireworms will eat stuff if it's there. It will only really work on light to medium infestations, and that, even that's uncertain. But we've seen, how do you determine whether that's light to medium, and is the cost quite high regardless? When do you apply it as well? If you apply it too late to your crop going in, is it going to do the damage? If you apply it otherwise, is the soil going to be warm enough? So you start to see all these conditions become a real barrier to actually trying to apply any of these control solutions. So you can kill these older install larvae, but making it a viable solution is quite difficult. And for different crops, there may be solutions to maybe target them a bit more specifically and incorporate it throughout that rotation. But there's no definite IPM program to do that so far. So we are taking that approach of trying to age out a population in a given area, and cover crops seem to be a possibility with this. But unfortunately, as you're starting to see, it's raising more questions than it is answers at the moment. Martin, do you want to add to that anything?
Yeah, I can add a bit. The product Atricap is a Swiss strain of Metrrhizium, Brillium, and Isopli. I think those two are interchangeable, aren't they, Ben? So it's not one or the other; they're the same. And as I understand. But there's various strains. Interesting that the Swiss strain works reasonably well in Austria, but it didn't work well at all in Norway. And wireworms are probably Norway, Sweden. I've got a meeting this afternoon with Lars Danielson from Sweden. And so the other thing you must understand is that there are many species, and up there, you're probably over in these colder climates, you're going to have a different mix. You're most likely going to have Obscurus. You're probably going to have Hemicrapidus athis, those kind of things as well. And Celatosimus could be. So you need to know what species you've got. You need to understand their life cycles. The Hemicrapidus is going to pupate in the spring. So you need to understand whether they pupate in autumn or spring. I think if you've got the right temperatures and moisture, then nematodes may be useful. I want to look at lure and kill in stubbles by using band treatments, but I haven't got there yet. But I bought a hand drill to drill the small plots. But yeah, you need to be going. If you can calm them down 3 years ahead, rotation. We'll cover that in a while. But yeah, look at the EWRN as well. Look at European. If you get involved in the European Research Network, we have some good conferences coming up.
Thanks, Martin.
More questions too.
Yeah, sure. I probably should have said, we're recording this and we'll be sending out a link to this later on. So yes, if you do need to go, as some people are doing, yeah, just know that there will be a recording available for you. Just before we go to you, David, Laura, can we pick one out from the chat maybe that I'm
there
missing?
was an earlier one from Dr. Bill Watts. What was the biggest challenge in the project, and if you could make one improvement to the trial, what would it be? And that's open to any of the speakers.
Well, basically the methodology of monitoring population change with particularly small larvae. That would be it's the technique, it's the technology we haven't got. I think the methodology would be, had we had a better method to identify larvae, small larvae in soil. That's what I would want.
And then there was another one in the chat just before we go to the hand up, if that's okay. And it's for Martin. Does the Canadian methodology of wireworm extraction from soil differ from the ADAS method? And that's from Dennis Buckley.
I'd have to look at that. Mainly, from what I understand, they're using bait traps. They mainly use bait traps. They either use the porridge method, but Christine and they do quite a lot of work on neonates with the actual small larvae. The problem is with doing that work in the field, as we've said, they've got same sorts of things as we've got, same limitations. But mainly when they're doing population control, I don't think that they use salt holic. I've not seen it mentioned. Their work in if you look at their cover, if you look at their in-field work, that's been done largely on damaging potatoes subsequently. And if you look at their the work on the juveniles, that's been done obviously in the lab.
Great, thank you. David, you've been waiting patiently.
Yeah, the question from Martin. I was interested to hear linseed being included in the list of possible kind of antagonistic crops towards wireworm, and that's really interesting because it offers a kind of viable cash cropping opportunity in the rotation, and then the potential to kind of build on that with a following cash crop of either mustard or buckwheat in advance of potatoes to sort of overcome the sort of criticism that the autumn crops are just providing a few months of potential constraint in the wireworm population. So yeah, I'd be interested to know kind of how convinced you are about the linseed in that area.
Linseed is anecdotally, I think Turner's book Linseed Law mentioned that they're reputed to drive wireworms out of the soil, which I don't think they will. If you go back to the 39-42 work, where they looked at linseed, it wasn't terribly well. It's one of those crops that isn't terribly damaged. If you look at that work, they reported that field beans were, and legumes generally, but field beans in particular, were providing lower populations after. Now, if you look at, I was looking at some Austrian work last night, and trouble with that, you have to get it translated, but they were talking about lower populations after beans as well. This is why we need to do these population studies. We know that field beans will survive a massive number of wireworms. I mean, I've seen field beans survive, and I've also seen Phaseolus beans survive after crops have been completely destroyed with wireworms. I've seen winter wheat taken out, and you need 1 million a hectare to take wheat out, and beans will survive that. Linseed hardly ever fails. When you actually get down to the suitability of feeding for juveniles, I would say that linseed, spring beans, even sugar beet, etc., they will, if you look at the methodology, not all crops are favoured for egg laying, and it will depend. If you look at, say, spring beans, for argument's sake, if you grew spring beans and you sprayed them for weevils, and the adults were swarming, then that pyrethroid would very, very most likely kill those adults present. So, you know, the whole modeling of a rotation becomes very complex. But yeah, crops, basically the cereals, they like cereals, they like grass, cereals and grass. So that's the broadleaves in the rotation. 3 years, 2 years ahead of potatoes are where your most damaging size are going to be. The 4th year ones are going to be pupating. I'm going to cover this later. 4th year ones be pupating July-ish. So, you know, so I'm going to cover that a bit later. But yeah, we need to know a lot more about rotation. But more than that, we discuss these things. Send you any date you want, David. That I've got anyway. Ben, have you got
Thanks.
any thoughts on that, Ben?
Apologies, I was actually answering a couple of questions in the chat, so I missed
yeah,
the
actually,
last bit of what you were saying.
If you wouldn't mind, let's go to Tony's question. I know there's in the chat, but that might not be surfaced in the recording. So,
yeah, sure.
Tony, do you want to? Good to see you. Do you want to just outline your question once more to Ben?
Yeah, thanks, Ray. So, I mean, I think mustard, I think has a really, really important role, but I think it does have a couple of limitations. So, it is a bit hit and miss. We've heard in this trial, but also, you know, I'm growing out in West Wales, and it's really, you know, quite difficult to rely on the weather conditions being right, being able to cut, being able to incorporate. So, I think it's tricky from that point of view. But I think I'm working mostly with horticultural growers, and the fact it's a brassica kind of puts a spanner in the works for subsequent crop rotations. So I'm really, really interested in buckwheat, or in fact any those approaches that don't involve brassicas. And I just wasn't quite clear what the mechanism was by which we thought that buckwheat was contributing to a reduction in population. So that was my question.
So if I just echo the thoughts I put in the chat, I know Griff will have comments on this from what Nick's put in the ground, and Martin will definitely have comments on this for the amount of contact he's had with Christine and the work that she's done with it. But the mechanism really is to suppress the population. Again, that concept we've talked about for aging them out by trying to provide unfavourable conditions for these early install larvae, which is what all these approaches are. Again, whether that is trying to cultivate and dry them out before they can move out of that uninhabitable area, or providing some sort of biofumigation or unpalatable conditions. So I put just a figure from one of Christine's papers in there. I'll find a link to the complete paper, which may be of interest to several people in the chat there. You found that the wireworm will feed on buckwheat. And again, I mentioned this in the very first presentation. They will feed on things, but they're not necessarily particularly palatable to them. You may find incidences where they could actually cause mortality because they'll still feed, but don't have the nutrition and will die before they're able to sustain themselves for long enough, or they may just reduce their body condition and thus their fitness to get to the next pupal stage, etc., etc. And that figure sort of illustrates that in terms of increasing some mortality, and then reducing their body condition as well. So what have they got there? It's weight and width of head capsule, which is used to really determine the instar stage which they're at for many species, and the next developmental stage. Martin and Griff, did you want to add anything else to the buckwheat discussion?
Martin, I'll just quickly intervene with a couple of points that I know Nick has observed, and I go back to one of the comments I made earlier. The challenge with using buckwheat in the overwinter mixes is the fact that it doesn't like cold weather, doesn't like frost. So I think that was one observation. It's like any of these treatments, it's the timing of it. And if you've got to sacrifice a crop, a bit like growing desist, we know it works, but it's the sacrifice. It's sacrificing a crop to actually put in the crop that you want to try and control whatever pest you have. So I think that would be his comments. If it works, brilliant, but it's then the timing of when you put it in the ground.
I think David's point was very valid, and it's what, and I'm going to cover that later on. And it is the crops we grow in the rotation we grow them in. So if you've got the same crops in the 6-year period, the order those crops are in, if they're different kinds of crops, can influence the population, stage, size, number. Christine's work, Christine told me that they were using common buckwheat, which is important because there is also Tartary buckwheat, which is a different species. We are not exactly sure if there are differences in the result, but they're different species. They wouldn't be different if they weren't species. If they didn't need to be different, they wouldn't be species. She said there's a chemical in linseed roots called acyl sucrose, and we're looking at work on leaf hoppers, and I gather acyl sugars are a control mechanism in the trichomes in leaf hairs, potatoes, I understand. Yeah, it's apparently their work indicated it was more attractive than barley as far as feeding. I've actually tried growing containers, small containers of buckwheat, and putting small larvae in. Work was inconclusive. Weight gain was the same, but the numbers were lower compared to wheat. When I turfed the containers out, they weren't that big. When I turfed the containers out, the containers with buckwheat, they absolutely stunk like a chemical store. Or when you turf the wheat out, it's got a lovely rooty soil type smell. I'm going to do some more of that. I've got to find myself some small larvae, from last year, and then I've got to get some work done. But 10 larvae weighed 35 thousandths of a gram, 10 of them. So we're looking at small critters here. The main driver of that 2-year work, 2 crops, 2 years, will be, I'm very, very confident that's egg laying, because similar work's going on in France. And Bruno and Gala over there said to me, Martin, they're not laying eggs there. We're actually considering looking at crops up buckwheat around the edge of the field to see if they will actually move through it. But all this is, there's a lot of hypotheses going on there. I'll leave that there.
Thanks, guys. Just track it, Phil. Actually, can I just invite you to make that comment that you've put in the chat again for the purposes of the video? And then Ben, again, if you could react to that, that would be great. Phil, are you still?
I just put a point about buckwheat. There was in fact an innovative farmers field lab on this a few years ago using buckwheat for cooch control. So it has a lot of benefits in the for organic growers, particularly in using it. And in that case, because it is killed by the slightest frost, it's used instead of a bastard fallow in the summer period. When it grows really fast from a sort of June, July sowing, so in a very short period. So you have to use it in its right time, just basically flagging up the potential other benefits of buckwheat. It's also good at mobilising pea. So it's sort of, and Ben responded in the chat as well that it was being used, the buckwheat is being used. There's a secondary benefit for the wireworm control rather than the primary reason for its being used.
Yeah, I think it's a really good point, and I mean it's arisen, right, because agricultural trends are towards having your fields covered year round, and what's beginning to become evident is soil is always the last thing to be studied, although it's becoming recognised just how important it is. But the ecological complexes within it are unknown as much in some ways as much as sort of the deep sea is, because it's not visible. How do we study all this stuff and actually what's going on between it all? And so pest control and IPM of these pests, as we're significantly changes in the way that we approaching managing our fields, is obviously going to change as well. It's just common sense, really, and we're just trying to get to grips with that. It may well be in some cases we're actually providing more favourable conditions for these pests to sustain themselves. But as with all these things, are we then sustaining their natural controls also? It's not to say that one is right and one is wrong. It's just that we don't understand it well enough, which is, again, what we're trying to do with the trial and other things.
Could I just follow on from Phil's point? I think it's a really interesting point you make, that if there was some more, if there was work that could strongly suggest that putting in some buckwheat would reduce the wireworm level, then I think growers, especially organic growers, would look to pop in a buckwheat at a different part of the year. So for Nick's situation, carrots or onions, so when a crop's been harvested early on, if there was a little bit more evidence, he would more than likely put in a crop of buckwheat, allow it to grow, and then put in another overwinter crop, just as in his normal situation.
Let's just incorporate. David, do you want to just? Well, maybe I'll read it out. Surely buckwheat killed after frost should usually not be a setback, as wireworm populations will already have stopped feeding and moved down the soil profile. If not, they still do not have an attractive food source available. Any comments on that?
Basically, if you get 2 degrees, if you get 1 degree of frost, it'll stop buckwheat, won't grow anymore. It'll hammer it. 2 couple of degrees, kill it. That temperature drop will go down in the soil. We see frost in September. Wireworms will still be feeding a month after that, because it doesn't get down the depth. It'll ding the buckwheat and kill it. I mean, I think in years to come, people will look at this and think we've got to understand the mechanisms of how these things work. And I would say, with all due respect to everybody, that if you wanted to control juveniles, you'd probably get a better result by just ploughing it and keeping it bare for a couple of weeks. But I understand that people want to grow things. Buckwheat seed isn't cheap. What we do need is, it's a useful crop, but a lot of other crops should be performing the same function. I mean, don't forget that the mustard in the Canadian work actually gave a better result. Obviously, we've got to be careful of mustards and clubroot, but I think if they'd done 1 buckwheat, 1 mustard, it would have a similar result. I mean, there's a lot that we can surmise all day long, but there is plenty of evidence out there, and we need to. Don't forget, you got to consider if they don't lay eggs, you don't have to get rid of them. Pretty damn simple, really. So, okay, we appreciate bigger larvae, but you've got to remember, if you look back at that Canadian work, and I've looked at it many, 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 many times, that there was still significant damage to potatoes after 2 years of buckwheat and mustard. It didn't kill the bigger ones. It couldn't have done. But when you actually look at, a lot of people have looked at this, a lot of people who really understand wireworms, and we're pretty confident we know what's going on. And don't forget, I have grown. I've grown in containers. I've grown cover crop mixes, including buckwheat, and the wireworms are still there in the spring. So it's not as just putting buckwheat in the ground isn't going to get rid of them all. It is not.
Hugh, there's an interesting point that Nassimo was put on from ADAS regarding the sampling that they did, the extraction.
Oh, thank you. Yeah, missed that. Okay, yeah, let's follow that then. How should we do this? Nassimo, do you want to read your question? Do you want me to read it?
Hello, I'm Nassim from ADAS. Yeah, so just what I'm trying to say in trying to share my screen. Hello, everyone. So we did the extraction for this project, and I just thought, okay, to give a word on what we did for the 2 years. We received the samples, and again, on our own part, we also had our internal project where we had Wireworm trials, and what we found using the same method of extraction. So we did receive samples from Richard Griffith, sorry, and obviously we tried our best to recover as much as we can from samples, and the results, as we reported to you, were what we found, and discussed in earlier on. It's not the best results that you will be expecting, and which is for me disappointing as well, because it would have been interesting to see an effect of one treatment on the wireworms. I also have to say that I also worked on cover crops during my PhD, so I do have keen interest in seeing what cover crops having an effect in soil-borne pests, and my PhD was on wireworms, not wireworms, sorry, on cover crops against stem nematodes. I did see some effect of cover crops. So I'm really keen in that work progressing. So, but I thought to also mention that the same method that we used for extracting of wireworming during this project, we use it for our internal trials, and the trials we set up, 2 trials we set up, were just coming up. The site were coming up from grasslands. So, and we had 43 wireworms per meter square in those sites. So I just wanted that to also to be recorded as well, that, and again, pose as a question, is it something that if the site were to be different, let's say we had a site that had that's coming up from grass, do you think that there will be difference in the results, or you think that that will be the same as you found?
Can I answer that? Yeah. The problem is with sampling methodology. It's not the extraction method; it's the sampling methodology. The threshold level for detecting larvae in soil is 62,500 using core samples. Now, I did some work on the Enigma project, and we actually took soil that we bait trapped, and we found 2.7 wireworms on average per bait trap, somewhere up to 10. The same measured area, we sampled it with the PCN corer, 2-inch corer, a 4-inch corer, and we corrected everything to a PCN sampling density to see if we could find wireworms. And although the bait traps had detected them very, very well, none of those methods found any wireworms that they could extract, and they did that and I think they did that in the nematology lab. So it's well known that Parker went through this in great depth, and we know what we're looking at we're looking at better methods to deal with this pest, to identify the pest. Yeah, we can go and find a grass field that's full of wireworms, and we'll find wireworms. 43 per square meter is 430,000. What is it? 430,000 per hectare. I mean, that's not even threshold for wheat, And if you look at the populations they had in the war, they were up to 8 million an acre, 5 million an acre. That's 10 million a hectare. So, the threshold at 60,500. I mean, I core sampled and we floated off after a failed potato crop. We didn't find any larvae. So that's my experience. I mean, I've done an enormous amount of work on detecting wireworms in soil.
Martin,
and that's what you're looking at.
Martin, could I ask you and Ben a question? If money had not been a constraint, Do you think if we'd have taken larger quantities of soil or sieved the soil in the field, do you think we would have found more, or do you think the levels that were in that field at the time we did the trial were as they are?
I'll jump in first. Two things, I suppose. I think, and it's difficult because I've also got this sort of experimental design background, right, where you want to plan perfect experiments, but you've got the pragmatism of field design. So I think if you walk into a field, you have a perfect place you'd like to put things, and then you have what's actually feasible in the day-to-day running of a field trial, and you're also restricted by how much you can physically do in terms of everyone's available time and everything else. So you would like to, in an ideal scenario, because everything is completely patchy within any given field, is sample an entire field, actually see where your patches are and put your field trial there to start with. And then when you're taking the samples for any given trial, you'd like to do it as regularly as is humanly possible to account for all these fluctuations that we've seen, whether that's temperature, the moisture within the soil, all of these things, and that's just not feasible. So on one hand, with money being no object and under ideal conditions, well, being able to do that a lot more often and being able to put it in an absolutely perfect place, we may well have seen more and potentially thrown up more of those neonate larvae. On the other hand, that's not necessarily how field trials work, and you don't know that for sure. If you can plan everything perfectly and throw all the money at it and do repeated sampling under every single possible condition and still end up with nothing, or you could have the complete opposite. So I think what we did under the conditions, and having seen the sampling effort, I think it was yourself, Griff, it was hard work, and you did a hell of a lot. Sod's law could be you take each of those soil samples a centimetre to the right, and you could have got everything. That's kind of the nature of the beast in all of it. I think we did exactly what we could do under the conditions. You've also got, when you're taking soil cores with relatively small trial plots, you're limited as to how often you can take those samples, because otherwise you're taking all the soil out of your sample plot. It's not like we're pan trapping for aphids, or we've got just a pitfall trap and we're looking for ground beetles. We're actually taking soil out of those conditions. So you've got a very different set of conditions you're trying to look for these things on, which of course is the difficulty we're working with subterranean inverts, unfortunately.
I mean, the thing is we use the only acknowledged method available to test population density in soil that actually gives you an answer to what population density in soil. We use the accepted methodology, and that's that. It's limited. We knew it was limited. That was mentioned at the very start. It was the limitation of the process was the technology we have available. So far, we still have the same technology available. You can DNA it in soil, but you won't find it's not quantifiable particularly. Anyway, we're going to run out of time if we're not careful.
Yeah. So let's move on to your segment, final segment, and maybe if you're able to do this in 10 to 15 minutes, you might end up picking out highlights of what you've got. I know there's so much information you've got. So let's get this sharing. This one, isn't it?
Yeah, right. If you maximize it, we'll bash on. Next slide. Yeah, that's what we're going to talk about. Next slide. So Ben has talked about this, so I'm not really going to go into it too much more, but in very, very, very sandy soil, we don't find populations. They need good soil. So it's your productive cereal growing type land, and they don't need grass, but they really like grass. But cereals are pretty damned effective at building up populations. And the important thing is the juveniles need something in the autumn, which is why we're doing this kind of work. But volunteer cereals, cover crops, volunteer cereals are equally as good as a cover crop. second cereals, equally as good as a couple, as long as if there's no cultivation in between. Next one, please. So what they do is they become active in the spring, as Ben said, but the population dynamics depend on the crop in the ground. So as we've said, some crops they prefer to egg laying, and then the success of the hatch. So if there's moisture, they prefer a humid environment. Eggs need moisture hatch. They need some food for the juveniles to feed on. And every year, we call it a year of grass. Did you have a year of grass equivalent or not? So if you had a cereal crop and it was some nice moisture in the soil, good land, and you left the stubble to regenerate in the autumn, that is about 75% of a year of grass equivalents. Next slide. Yeah, briefly, that's a graph of when they're active. They start, certainly where I am, done a lot of work on this. That 5th year of adult, well, this year will be my 6th year of adult trapping. We use various methods. We use not just pheromones, we use other methods as well. But yeah, your peak is typically going to be late April on Sputata. Over here, they get going a bit faster. We don't have the lineatus over here they have in the West. Obscuras are absolutely omnipresent across the whole of the UK. Sputata tend to peter out once you get about up the Humber. Next slide, please. So we talk about the oldest larvae, we assume they pupate in the 4th year of their life, but we don't know. And there's data from Switzerland, from Agroscope, indicating that 60% of Sputata will do a life cycle in 3 years, I think it is. So, and Sputata are pretty similar in the pecking order to our friend Sordidus, which we can't find here. But if that is the case, and it may be less so the case in southern warmer areas, but it is 2- and 3-year-old larvae that are doing the damage most likely in the later part of your crop bulking, so August, September. They're not likely to be pupating that late. So the 4th year ones will have pupated off. If you've got salad crops, they are relevant. If you've got the main crops, they will have done damage, but the larvae that you find feeding in sort of September will be most likely be the 3rd and the 2nd year ones, or they'll actually be in their 4th year then, 4th and 3rd years. So, and crops that increase populations 2 to 4 years ahead of potatoes are listed there. Cereals, short-term lay, spring cereals, followed by green cover. I've seen enormous numbers of wireworm in fields, 6 years of spring barley, just stubbles cultivated. They were there. And basically, if you've had permanent grass, the field remains at elevated risk for a long time. Next one, please. Yeah, options to reduce them in the population are broadleaf crops 2 or 3 years ahead of potatoes to reduce egg laying. And as I've said, insecticides in peas, and that can kill adult beetles when they're active. We need to do more work on rotational risk, but we know that broadleaf crops are less risky than our cereals. And if you've had a cereal crop 3 years ahead of potatoes, I would be looking to cultivate that fairly deeply as soon as I could after cereals, after harvest, and keep it relatively free of vegetation for a month. You can stick a cover crop in after that, and I would avoid cereals in that cover. Next one, please. Basically, we know that damage isn't it is not homogeneous across fields, and the areas listed there, this is all going to be recorded, these presentations will be available. The areas listed there, you want moisture and reservoir areas of large grass, but in-field actions are incredibly relevant, even if you've got old. So you can have situations that look very high risk and you won't find wireworms. It's because what's happened in the field has taken them out. Next one, please. So yeah, we're looking at this. This is some area I do some work, a bit of work, and we've got south and west facing sloping land next to a river with grassland at the bottom, and we do some good wireworm trials there. An irrigation reservoir can build you up a little damage area, and you'll get quite significant damage on headland next to an irrigation reservoir. Any permanent grass they'll wander in from there. They don't fly much. Next one, please. Yeah, so much as I've said, if you look at the features on that map, we've got grass to the right, we've got grass to the south. That's where the wireworm damage was. I set 700 tubers out of that field, and that was a salad crop. and we had 6% near the solar farm, 12% up near the reservoir. And you monitor and dig. You dig and monitor, dig and wash, and you start early. There is the idea is that they come in after burn off. Well, if you burn off in July, they will, but not other times of the year. They're already there. Next one, please. Yeah, quick Venn diagram. I mean, these things look, I do like it. It makes me look intelligent if I can create something like that. Take more than that to really, though. But I mean, basically, what you're looking at is the factors there: cultivation, soil type, and the crops in the rotation. And the sweet spot is: do they provide somewhere to lay eggs? Do they provide post-crop food source? And basically, are you getting juvenile survival? Next one, please. Yeah, Ben said this. I've said that basically. Yeah, we've said that before. Let's go on. Next one, please. Yeah, risk assessment. This is going to be quite useful. So you can see it you can actually see the damage in cereal crops. I found low levels of wireworm damage in a wheat crop, and I found a significant number in the stubble after that wheat crop. As a last resort, walking behind a destoner, as long as the soil's above 8 degrees, you can find wireworms. It's a very useful method, just to working out where they are in the field as well, but it's time consuming. Next one, please. Yeah, these are the kind of bait traps I use. I don't necessarily have the mesh in them. There's various ways of doing it, but the difference, the two pictures, the third one along, the trap on the left has grown, average soil temperature 8 degrees, data logged every hour. The one on the right averaged 6 degrees. That was simply not covered with plastic, and around about 3 to 4-fold difference in larvae catches in those traps. Some work I was doing validates Simagrio in the UK. Next one, please. That was autumn trapping, by the way. Yeah, you can bait trap in the autumn, you can bait trap in the spring. At the moment, we haven't been able to bait trap. It's too damn cold, and we've got potatoes going in, and I've got to go and walk behind a destoner tomorrow because just to see what's there, because we're just not going to get there with the bait trap, and you're going to need a couple of weeks really to bait trap in the spring, and farmers will be wanting to get going. So we bait trap in the autumn. It is successful, and as David Nelson will say, don't the badgers damage them. My best so far is 22 traps taken out of 24, David, and I think you would have wet yourself if you'd seen me at the end of that. The soil must be over 8. It must average over 8, not peaking at 8, averaging over 8 during the trapping period, not waterlogged or bone dry. So really just sort of conditions of crops growing. And if you do it in a cover crop, your carbon dioxide that's released will be swamped. This is some work we did, and the soil and the soil temperatures dropped, and the bait trap work. It's James Howell's basis project. That very good piece of work. Maize, wheat, or wheat barley will do, but it must be untreated seed. Next one, please. Yeah, it's important that you've got to identify what you find. The one on the right is stiletto fly larvae. I always say to people, if you're finding larvae, farmers go, "Oh, I found a wireworm, I squashed it and killed it, bloody thing." And I say, well, there's not a lot of them. They're not all predators, and I can't identify pieces of larvae that have been described to me. So that's a stiletto fly. They can give you anaphylactic shock. They are wireworm predators. Next picture, please. The next slide, please. Yeah, here's some soil-dwelling insects. The one on the left is a wireworm. It's Agriotes wireworm. The one to the right of that is a mealworm. They may have a pest status. They are present in the UK. I find them in sandy soils. Stiletto fly, very, very rapid moving. And then we've got some other beetle, carabid rogue larvae, whatever they are. Hemicrepidus on the right, number 1. Number 2 is a centipede. Number 3 is a millipede. And so with all that lot on there, there's only 2 wireworms, and there's 2 different species there. Next one, please. Wireworms have 6 legs, by the way. So I'll put these pictures in the different genera we get in the UK. So the 2 on the left, top, Hemicrepidus, and then the next one down to Agriotes. The one smack in the middle is an Athus. There's about 5 species. They can be quite damaging crop pests. The one top right is not. I had 120 of them in bait traps this year. We grew Maris piper. We harvested it end of October, early November, and they had no damage. And Agrippinus at the bottom is not considered to be a pest species. Very, very, very predatory. In fact, on there, all of those wireworms will be predatory, but the least predatory one is the Agriotes. Next one, please. And yeah, this is what you look at, the ninth abdominal segment, the tail section. The one on the left is Agriotes. That is distinctive for our main Agriotes. And the pictures on the right describe what you're looking at. You need a decent lens to do that. Next one, please. And we've got a table here, basically just a bit of an idea as to what you've got. They're variable. The cuticle gets darker as it ages. And actually, you can have pure white wireworms or creamy white Agriotes the day after they molt, and they turn beige within about 24, 48 hours. Next one, please. This just indicates the relative food gut content of different species there. And we don't have ustulatus. We don't have many sordidus in the UK. We have all the others. Next one, please. And it clearly shows the Agriotes are they're plant feeders. So the assessment, the risk assessment summary is you can bait trap autumn or spring. You can look behind a de-stoner, and conditions are critical, but it says what they are there. Next one, please.
We go for like another 3 minutes, Martin.
Yeah, well, I will. Carry on, please. Varieties and damage. Basically, varieties are dramatically different. Baby Lou, Melody there, I'd like to see a bit more work on Melody. There's some question about anything around the middle area. They can be all over the place. We know that Innovate is bad. We know that quite a lot of varieties are bad. Marfona's bad. I mean, Marfona doesn't look as bad there as I would say it can be, but there's a lot of varieties there can be very bad. But Innovator, very interestingly, very bad. Baby Lou at the other end, consistently quite good. It's depth of feeding that makes the difference. Next one, please. Yeah, that's just two varieties, same trial. Remarkable difference. Next slide, please. And yeah, that's two harvest dates. We had a significant increase in damage over 6 weeks. We see this consistently in cupcre work. Next one, please. So we're looking at the depth of feeding is massively different between varieties, and variety plus early lifting makes the biggest difference. So we've had 50% reduction consistently from harvesting 6 weeks earlier, and variety adds more to that as well. Variety makes a big difference, but there are not many really good ones. Next one, please. Yeah, summary. I'll flick through that. So next one. Date of harvest is the biggest single influence. Next one, please. Yeah, this just shows you from some stuff in Spain that was done, and the nematode there showing up quite well. Nothing else really coming close. Nothing coming close really to mocap, but the tefluthrins, if we get them, will give us a benefit if we get them. Next one, please. Yeah, that's it really. I can't say a lot more than that. We are looking at entomopathogenic nematodes. I think they could, some of the species, they need to be thinner, not big, fatter apparently. But yeah, that's a bit where we are. I think I'll call that a day there, Hugh. Is that okay?
Thank you so much, Martin. There's just such a wealth of knowledge. And am I right in thinking you're okay with having that presentation shared with the? Yeah, we're going to send an email out, Laura, I think, with a link to the webinar and also the final report, and the presentations. I'll just double check that with participants, but I think that's the plan. Yeah, we tried to, when we were planning this, I thought, well, we wanted 2 hours in case, it felt like a good amount of time, and it's we wanted to give you a lot of technical information on the trial, but also give space for the discussion. So that's why we've kind of come back to a bit of dissemination at the end. Almost, we probably could have had a whole day really on this. So yeah, really, really grateful to Griff, Martin, and Ben for your time on this trial and exploring this topic and together, and just listening to your wealth of knowledge. And there's been a lot of laughs along the way. and also, yeah, difficulties with the trial and understanding all of the complexities that goes on with conducting a trial in the field. It's been fascinating. So big thank you to you and for your time today, and everybody that's joined us. Really grateful to see such an interest in this topic. So let's say a minute early, we'll give you that back. Yeah, really good to see you all. Take care.
Thanks all.
Thanks.